Finding the epicenter. Seismometers are located all over the world. The seismic station in Montana can detect waves from an earthquake occurring in California or Alaska. If the earthquake is really strong, seismic stations on other continents can record data from the same earthquake. How? P waves produced by an earthquake travel through solids, liquids, and gases. They can travel through the Earth's interior to any point on its surface. Seismologists analyze and interpret data to determine the location and strength of the earthquake. The point where the earthquake occurs from where its energy is released is called the focus. The focus can be shallow or deep. A shallow focus is up to 70 kilometers or 25 miles below Earth's surface. An intermediate focus lies from 70 to 300 kilometers or 25 to 186 miles below Earth's surface. A deep focus lies below 300 kilometers or 186 miles. In general, the shallower the focus, the stronger the earthquake. The point on the Earth's surface directly above the focus is called the earthquake's epicenter, as shown in the illustration. So you can see in this photo here, we have our epicenter right in the middle and then the focus around it. A news report may refer to the epicenter as the location of the earthquake. The pattern of damage from greatest to least moves outward from the epicenter. In other words, the farther a structure is from the epicenter, the less likely it will be damaged. Damage from one earthquake can occur in many different places. Seismologists use math to pinpoint the exact location of the Earth's epicenter. First, they use the arrival times of the P and S waves, as shown on several seismograms. Then they plot those times on a special graph called a time-distance graph. P waves travel faster than S waves. Scientists can graph the speeds of both waves on a special graph. An S wave always travels more slowly than a P wave. The distance between those two becomes greater and greater as time passes. If you know how many minutes apart the two waves arrive, then you can calculate the distance they have traveled. That is how far they are from the epicenter using a time-distance graph. In much the same way, scientists observe when each waves arrive at the seismic station. By subtracting the distance and arrival time of S waves and P waves at a seismic station, seismologists can determine the distance to an earthquake's epicenter. The greater the difference in time between the P waves and S waves arrival, the farther the station is from the epicenter. Is that enough information to pinpoint the exact location of the earthquake? No, because earthquake waves move out from the focus in all directions. It is like ripples when a rock is dropped in a pond. With data from a single station, the seismologist knows only that the epicenter could locate anywhere within the circle around the station. With data from two seismic stations, the location is narrowed down to two places. That is, the 2 points where the circles cross each other. But with the data from three stations, all three circles intersect in one location, as shown on the map below, the point of the epicenter of the earthquake. So you can see here we have our three circles, and this red point shows the epicenter and approximately where it'll be located, because you can see all three of those circles overlapping each other. So you wouldn't have anything here where only two overlap, or here or here. And that is all.